Good morning, everyone. Welcome once again. My name is Keira Proctor, and I am the Managing Director of the Proctor Group Limited. And this is our fifth webinar in our lockdown series. If you're a regular to these sessions, welcome back. If not, then the full series is available on our website at www.proctorgroup.com or our YouTube channel. Today we're going to be talking about pitched roofing and how to avoid condensation problems. Our roof shield membrane first launched in 1996, and it was granted a BBA certificate for use in non-ventilated cold pitched roofs in 1999. The product we sell today is more or less the same material as it was then, with a few tweaks and upgrades. Over the years, we've seen this market go from a small number of houses to mainstream use by major UK house builders and supplied a huge variety of projects around the world. Not only that, but non-ventilated pitched roof construction is now not especially unusual, and spotting the green roofs around the country and even on TV news broadcasts happens often enough that our families are getting pretty bored of that game now. We hear a lot from customers, both installers and specifiers, that what they like most about Roof Shield is that it just works, so they can specify it and fit it without worrying about any hidden problems or unusual detail. So for today's presentation, we're going to look at why that is. We'll start out with the basics of condensation, why and where it forms in roofs, and some of the critical factors that influence our designs. We'll then move on to look at the legislation, regulations, and codes of practice that relate to underlays in pitched roofing. We'll also discuss the various types of underlay membranes available today and why the differences between them are important. Then we'll finish up with a look at some projects and practical applications before moving on to our regular live Q&A session. If there's any question you have, feel free to type them into the YouTube box, DM us on Twitter at Proctor Group, or email webinar@proctorgroup.com. So what is condensation? Condensation is the formation of liquid water when warm, humid air comes into contact with a cold surface. The warmer the air in an environment is, the more water vapour it can retain. However, when this moisture-laden air cools down, its capacity to retain water reduces, and this water will turn back to liquid. The most common example of this is bathroom mirrors and windows, where the warm air in the bathroom can support a lot of moisture from, for example, a shower, but when it hits the cold surface of the mirror, it loses this ability, causing the mirror to fog up. You can also see this happen with cold drinks or on car windows. If we consider the building envelope as a whole, the habitable internal spaces are usually fairly warm and humid, which creates what is called vapour pressure, and this is the driving force that creates condensation risks. In the UK and other climates where heating is more prevalent than cooling, this process mostly works from the inside to outside, pushing that internal moisture into the walls, floor and roof of a building towards typically cooler and less humid conditions outside. As well as showers and bathing, there's a number of other moisture sources present in buildings. Cooking can produce a fair amount of water vapour, not only through the obvious source of water boiling in a pan, but also a byproduct of the combustion of certain gases. Cooking can also raise the temperature of a room, which in turn can increase humidity in the air. Laundry is also a significant moisture source, both from steam irons and drying out clothes. Clothes being hung over radiators to dry out is one of the most common causes of condensation and damp problems arising in housing. But tumble dryers can also boost moisture loads if seals or ducting are damaged or missing. Finally, the building occupants themselves produce a lot of moisture through breathing and sweating. Even while sleeping, this represents a substantial source of moisture, and activities such as sports produce significantly higher moisture loads. When considering condensation control strategies, the activities taking place in the building are among the most important factors. A successful moisture control strategy for a warehouse, for example, would look very different from a care home. So how does this internal vapour pressure give rise to a condensation risk? The insulation in the building fabric helps keep the indoor temperature more or less constant, but as we move outward through the building element, the temperature will drop sharply across the insulation layer. As the temperature drops, the air loses its ability to retain water. At a certain temperature, the air will become saturated and lose its ability to contain the water vapour. This temperature is known as the dew point temperature and is a product of the vapour pressure at a given point in the structure, as well as the vapour resistance of the individual layers in the construction. Provided the actual temperature remains above the dew point temperature, there will be no significant risks of condensation occurring. To prevent these risks, the moisture vapour must be removed from the roof space sufficiently quickly that the vapour pressure does not reach the saturation point and lead to the formation of condensation. Traditionally, this is achieved by way of ventilation, where incoming air dilutes and removes the vapour, reducing the vapour pressure to acceptable levels. An alternative method to reduce the vapour pressure in roofs is to use a vapour permeable underlay membrane. Similar to a breathable Gore-Tex jacket, this type of roof membrane allows moisture vapour to escape from the roof whilst preventing the ingress of liquid water. If the roof system, whether it be ventilated or uses a vapour permeable underlay, is not designed to adequately deal with the moisture loads it will be subjected to, then air in the loft can become saturated, reach its dew point, and this is what leads to condensation forming. These water droplets on the underside of the roof underlay can drop into insulation or items in the loft, or can soak into roof timbers. If this moisture is not capable of drying out, it can lead to a variety of negative effects. If condensation leads to persistent damp in a specific area, it can cause damage to the internal finishes. This damage can range from discoloration to growth of mould spores. Mould spores within the livable spaces of a building can give rise to serious health problems for the building occupants, particularly children, the elderly, or anyone with respiratory problems. Damp spots and any subsequent mould can be an indicator of cold spots, such as at junctions, corners, or areas where there is substantial cold bridging. Surface mould can also be an indication of poor air circulation internally, such as behind furniture, at the back of built-in wardrobes, or in specific areas of attic spaces. Some insulation materials, particularly fibrous types like glass wool, will absorb moisture arising from interstitial condensation, and since water conducts heat better than air, this will reduce the insulation's performance. If the dampness is caused by locally reduced temperature, such as a cold bridge or air leak, this decrease in insulation performance will increase the rate at which further condensation will form, resulting in a vicious cycle of degrading performance. In most cases, timber will begin to rot if the moisture content is above 20% for longer than 60 days. Rotten timber structures will severely reduce the lifespan of the building, so it's critically important to ensure moisture is managed to avoid this. It's also important to remember that as timber absorbs water, it may well swell and distort due to expansion. The converse is also true. If the timber gets wet and swells during construction, it may subsequently shrink as it dries, which can also lead to problems. Although metal elements are generally more resistant to moisture damage than timber, they are not immune, and the corrosion of metalwork can weaken structures. Corrosion damage to metal elements like roofing sheets can also lead to further moisture problems due to water ingress in adverse weather. Water ingress into electrical services and network cabling will have obvious negative effects, but it's also worth considerations that any structural distortion due to swelling timber or corroded steel can also affect building services by overstressing cables, pipes, and conduits. There are two principal issues associated with items stored in lofts. Firstly, damp conditions can lead to damage due to mould growth or rot. Secondly, items in boxes can block roof ventilation or obstruct airflow, which can lead to problems in otherwise well-designed and constructed roofs. In this respect, non-ventilated roofs are typically more robust over the long term, as there are no ventilation openings to block. Design considerations. We'll now take a look at some of the factors affecting pitched roof design and how we can design out condensation problems from the start. The building fabric, typical weather conditions, and the anticipated occupancy patterns and uses will all interact to define the moisture risks associated with the construction. These ground rules must be identified and understood to form the basis of a good hygrothermal design strategy. Once an understanding of the building, weather, and occupancy is achieved, the designer can then focus on ensuring the heat, air, and moisture movement within the structure is properly balanced. This ensures both a healthy environment for the building's occupants and a long life for the building itself. This balance is the basis of Ham principles in building design. While the wheel of building, weather, occupants, and heat, air, and moisture looks simple enough, there's a great deal many additional factors to bear in mind when we look into these areas in more detail. The precise nature of the project and its requirements has a big effect, and we'll now take a look at some of these factors in greater detail. Refurbishment. In refurbishment projects, there may be pre-existing condensation issues to resolve, particularly relating to convection tightness and cold bridging. Older structures were not usually designed or built with much thought given to these issues, so it may be not that straightforward to fix these issues or problems either in practice or economically. The building may also have been modified or upgraded over its lifespan, and additions such as double glazing, blocking up chimneys and ceiling drafts may have created condensation issues which did not exist before. Modern materials may also have very different hygrothermal properties to those they replace, such as gypsum plasterboard compared to traditional lime plaster. This might require special treatment in order to avoid problems, necessitate sourcing unusual materials or skills. Timber frame. Timber frame buildings are typically built under drier off-site conditions, which not only reduces initial moisture loads, but means a wind and watertight envelope can be achieved in less time. Tighter tolerances and better quality control also help reduce problems, but this might mean the building is less able to tolerate issues arising from poor installation or damage to prefabricated elements that might occur. Traditional build. Traditional masonry buildings will have higher moisture loading from wet trades and a less precise construction process that places greater emphasis on good workmanship on site. They do, however, have a better fabric heat storage characteristic, which can help stabilise temperature swings, and the inherently leakier and more permeable construction can reduce the risks associated with trapping moisture, provided this permeability is properly accounted for in the design process. Surface condensation. If the wall is cold and poorly insulated, the dew point will occur on the internal surface, which causes surface condensation. This is fairly common in bathrooms and kitchens, particularly in older properties which may have solid brick or stone walls. Interstitial condensation. If the dew point occurs within the fabric of the building element, this produces what is called interstitial condensation. This is most obvious in lofts with poor ventilation or low-spec, vapour-permeable underlays, but it can also be hidden completely within the element. It is therefore important that designers ensure this does not occur, as it may be invisible to the occupants. Vapour control layers. Adding a vapour control layer at ceiling level will help reduce condensation risks, but vapour control layers are only as good as the quality of their installation. Any penetrations or breaks in the membrane, such as downlighters or cables, pipework, can reduce or eliminate its effectiveness. It's therefore preferable if the roof system can prevent condensation with the lowest requirement for vapour control possible. Reverse condensation. It's also possible to have reverse condensation, which occurs where the indoor conditions are cooler and less humid than conditions outside, in which case the normal vapour drive is reversed. It's very rare that this occurs in climates like the UK. However, in some specialist applications such as cold stores, it's worth bearing this in mind. It's more common in warmer locations such as the Middle East or southern US. Sarking boards. The use of sarking materials such as plywood or OSB or traditional softwood planks will have a big impact on the way moisture flows through a loft. Some underlay membrane certification may impose additional requirements or restrictions on its use. Traditional roofing practice, such as the Scottish method of slating directly onto sarking boards with no battens, will be different again, and any membrane specified for this application should have full certification for such use. Complex roof shapes. Finally, the physical layout of the roof has to be accounted for, and particularly complicated roofs might pose problems when it comes to ensuring all areas are adequately ventilated and there are not dead spots where moisture-laden air can accumulate and condense. Subdivisions of roof areas, for example, for fire compartmentalisation can further exacerbate this issue, as can specific architectural detailing or the overall aesthetic, which may preclude adding additional ventilation. Roofs with a combination of warm and cold areas, such as rooms in the roof, may result in different requirements across the various different sections, depending on the specific conditions given in membrane certification. If the roof is to be ventilated, then care must be taken to ensure there is an adequate airflow across the entire roof. The degree to which membranes must be draped and whether or not counterbattens are used is another important area that must be considered. This ensures both adequate drainage in the event wind-driven rain penetrates the slates or tiles, but also may be required to ventilate the batten space if the roof covering is not air open. Conditions and requirements for battens and draping are given in membrane certification. The air openness of the outer covering must be accounted for, and if the tiles are particularly airtight or if metal roofing coverings are specified, additional venting of the batten cavity may be needed. BS 5250 and BS 5534 outline when coverings can be considered air open. It also outlines which measures must be taken if they are not, and what effect wind uplift will have both on the outer covering and the roof underlay. The effects of this are discussed in BS 5534, the Code of Practice for Slating and Tiling, so let's move on to discussing that and other relevant codes and legislation next. BS 5534. As well as condensation control, an important factor in roof design and underlay specification is the effect of wind uplift forces on the roof system, and this is covered by the Code of Practice for Slating and Tiling, BS 5534. As wind blows over a roof structure, the airflow presses on the windward side, creating a downward force, the wind pressure. On the leeward side of the roof, the airflow reduces the pressure, creating a suction which pulls the roof upwards. This is the wind uplift force. These two forces act on the entire roof system, and the starting points of this chain of forces are the outer covering and the underlay membrane. The resistance to the uplift force is shared between the outer covering and the underlay depending on the air openness of both parts. Whether a roof system is airtight or air open affects the degree of wind uplift resistance, and how the air permeability varies across the various components in the roof also has an effect. It follows, therefore, that wind uplift forces will have a greater effect on airtight systems than air permeable ones, as airtight systems will resist the flow of air by their very nature. If the roof is not correctly designed to resist wind uplift forces, then in extreme cases the tiles or slates of the outer covering can be damaged. This damage will be mainly caused by uplift forces, directly removing the slates or tiles by sucking them up and off the roof. In theory, it could also occur due to the underlay membrane ballooning and pushing them off. Although there is little of any conclusive evidence of this occurring, the 5534 standard sets criteria for underlays to resist wind forces and divides the UK into 5 wind zones. This table gives the uplift resistance force for the roof shield membrane for each installation configuration, along with the measures that must be used in a given wind zone. As we can see here, in zones 1 to 3, no special measures are required at 345mm batten spacing. However, in the more extreme conditions of zones 4 and 5, designers will either need to reduce their batten spacing to 250mm, fit counter battens or tape joints. If, however, they are using the traditional Scottish slates into softwood sarking detail, then use is unrestricted in all zones. BS 5250. The other important document relating to pitched roofing design is BS 5250, which we first discussed in our lockdown webinar a few weeks ago. The BS 5250 is the Code of Practice for Condensation Control and is referenced by the UK building regulations which do not address the specific of condensation control directly. There's a committee working on updating the BS 5250 right now, and there should be a document out for public consultation soon, but under the circumstances it might take longer than expected to get this revision completed. The process isn't the quickest at the best of times, but it's very important to get these standards right as they affect so many different aspects of our designs. We'll certainly be running a webinar on the changes when they're ready to go into effect though, so please keep an eye out for that. BS 5250 gives specific detailed guidelines on how to ventilate all types of roof, but it does not address non-ventilated roof construction, instead referring the designer to specific third-party guidance if ventilation is to be omitted. This is typically a BBA certificate, although any relevant and equivalent European technical approval document can be used. As well as outlining ventilation requirements, BS 5250 defines performance criteria for types of roofing underlay. These are HR underlays, traditional non-permeable underlays such as bitumen felt, with a vapour resistance greater than or equal to 0.25 meganewton seconds per gram, and LR underlays, which are modern breathable felts, with a vapour resistance less than 0.25 meganewton seconds per gram. HR underlays will always require the use of ventilation, while LR underlays can be used without ventilation, provided third-party certification is available and its conditions are adhered to. BS 5250 also recognises the benefit of air permeable membranes with regards to condensation control, but does not define any performance criteria in this area, again leaving the specifics to third parties. HR underlays and vents. For type HR underlays, ventilation openings are typically required at the eaves and/or ridge of the roof, so to ensure sufficient airflow is provided to remove moisture vapour from the loft space. Whether ventilation is needed at both eaves and ridge or at the eaves only, is dictated by the size and shape of the roof, as is the size of the openings required. LR underlays. When using an LR underlay, the vapour can escape through the entire roof surface, driven by the internal vapour pressure. In theory at least, that means air movement through ventilation is not required. However, as we've discussed, BS 5250 does not directly address non-ventilated roofing membranes utilised without ventilation. Therefore, they must be covered by third-party certification, such as BBA, BM Trada, etc. Conditions for use of such membranes are given in these certificates rather than BS standard, and if ventilation is omitted, these conditions must be adhered to. Product certificates and technical guidance documents go into a lot of detail about these specifics, and these details may include requirements to use vapour control layers at ceiling level or to specify insulation with reduced vapour permeability. Features such as sarking boards or dormer windows may not be covered by product certification or may impose additional requirements. Even apparently simple things such as the amount of drape required or if counter battens are needed can vary between membranes. This variation means it's important to have a good appreciation of the different membrane types available, so now let's take a look at some of these in more detail. A great many membranes meet the LR spec from BS 5250, however, within this spec there can be significant performance variations. Here we can see 3 different LR membranes installed on the same roof. While there is a lot in common, the specific product certification for each membrane will have subtle differences, so whilst all are broadly suitable for this application, the specific detailing required and the overall performance may vary considerably. 2-layer flash-spun HDPE. Flash-spun HDPE membranes are typically 2-layer products and are vapour permeable whilst being air and watertight. In general, the vapour permeability for these types of membranes is at the lower end, but they provide an effective air barrier which can theoretically improve energy efficiency in applications where they can be specified with no ventilation, but will require the use of either a vapour control layer or a well-sealed ceiling. PP Film Laminate. Film laminate vapour permeable membranes are typically composed of 2 outer layers of polypropylene with a film core. More of the vapour permeability and water holdout performance is governed by the film layer. However, it is quite fragile, so the outer layers serve primarily to protect the film core from damage. Film laminate membranes are typically airtight and are similar to flash-spun membranes in terms of vapour permeability. They do tend to have slightly higher water holdout performance. However, all membranes used in roofing application meet the relevant W1 waterproofing standard. As with all airtight membranes, film laminates depend purely on vapour drive to transport moisture out of the roof, so they may be less able to cope with excess moisture loads, and as such may require the use of vapour control layer or additional ventilation. Film laminates are the most common type of vapour permeable underlay. It's also worth noting that a lot of film laminate membranes are rebrandings of the same base material. Examining the details in the product certification will reveal if this is the case. PP melt-blown. Polypropylene membranes with a melt-blown core, such as Roof Shield, replace the microperforated film core with a layer of microporous fibres. This comprises a matrix of fibres many times smaller than a human hair, which allows the smaller water vapour molecules to pass through while larger water molecules are blocked. Membranes with a melt-blown layer offer a higher permeability to water vapour, further boosted by air permeability, which provides actual air changes through the loft space. This comes at the expense of a slightly reduced water head compared to other membrane types. However, as the membrane still meets the required specification for the W1 weather tightness standard, this is of little importance. Because the membrane is also air permeable, excess moisture loadings are easily accommodated, greatly reducing condensation risks and meaning there are fewer restrictions of the use of such membranes. Vapour control layers and additional ventilation are typically not required for common roof constructions. In these roofs, the air-permeable underlay allows airflow through the loft, as well as the vapour drive pushing moisture from inside to out. There are actual air changes taking place. This not only increases the ability of the roof system to transport the moisture vapour safely out of the building, but makes it harder for condensation droplets to form on the roof underlay. This distinction in membrane types is particularly relevant with NHBC projects. In 2012, the NHBC released this guidance document in response to complaints from homeowners regarding condensation issues. These complaints noted condensation appearing over the winter months shortly after completion, while the excess construction moisture from screeding and plastering was still drying out. This is generally discovered by homeowners unpacking Christmas decorations. To remedy these problems, the NHBC mandated that roofs with low resistance type LR underlays should be fitted with an additional 5 mm of ventilation openings at the ridge only. In theory, this open ridge boosts vapour transfer during the drying out period after completion. In practice, though, the airflow out of the ventilated ridge is inhibited by the lack of air inlets, so it's not clear that this approach makes a big difference to condensation risks. In addition to the 5 mm ridge ventilation, the ceiling must also be well sealed as defined in BS 9250. Aside from the obvious requirements like not having any gaps or cracks in the ceiling, this standard sets air leakage requirements for hatches and downlighters and requires sealing of service penetrations using suitable proprietary products, all of which can complicate the design and construction process and potentially introduce unforeseen costs and delays. Another concern here is that by introducing a 5 mm gap at ridge, there is an additional pathway for water ingress, both during construction and in the event of damage to the primary roof covering. This means that the roof cannot be considered watertight until the roof covering is completed, delaying works on internal finishes and services that could otherwise be started. Finally, this gap means that the roof is not airtight, negating the energy performance benefits used as a selling point by airtight underlay manufacturers. It also places a lot of emphasis on the quality of the ceiling installation. Which can be an issue if electricians, plumbers, ventilation installers, etc. are not aware of the specific requirements of BS 9250. So given these issues with the NHBC guidance, is there a way we can avoid this? The same NHBC document includes an exemption to these rules. However, this is not referenced in the main NHBC standards documents, so may not be immediately apparent. The way around adding the ridge ventilation is to use an air permeable membrane carrying appropriate certification. This allows the use of completely unventilated roof constructions. Our roof shield membrane is BBA certified as air permeable and therefore qualifies under this exemption and can be used without ventilation or vapour control as detailed in Section 7 of the certificate. As one of the first companies to advocate non-ventilated roof designs, we've always taken product testing and evaluation very seriously, and there's a sound basis for the difference in requirements between airtight and air permeable membranes. The testing this is based on was conducted in the early 2000s at BRE Scotland. The Partners in Innovation PII project, Improved Thermal and Moisture Performance of Pitched Roofs, was undertaken by the BRE and Glasgow Caledonian University and completed in 2004. The aim was to test and model the performance of different types of LR underlay and compare these results to conventionally ventilated roofing. The 4 test cases were as shown here, and prior to testing, all 4 test rigs were pressurised to determine the equivalent ventilation openings that would be necessary to replicate the air leakage characteristics of the unventilated roof. In the worst case test, not only were the loft hatches unsealed, but they were left open, and the moisture load increased using heated water baths to simulate an open hatch in a humid bathroom environment. The combined effect of this is to raise the temperature and the vapour pressure in the loft, making it more likely that condensation problems will occur. During the extreme test period, heavy condensation was noted on the underside of both the airtight LR underlay and the traditional roofing felt, while the air permeable underlay on the first pair of roofs was free of moisture. In these roofs, the air permeable underlay allows airflow through the loft, so as well as the vapour drive pushing moisture from inside to out, there are actual air changes taking place. This not only increases the ability of the roof system to transport the moisture vapour safely out of the building, but makes it harder for condensation droplets to form on the roof underlay. It is because of this testing that both BS 5250 and the NHBC recognise that the air permeability of roofing underlays plays a significant role in reducing condensation risk in pitched roofing. There has always been a concern when using breathable fabrics that water may track into the roof through holes made by fixings, particularly if the membrane is not draped to provide a runoff channel. To put this concern to the test, nail sealability testing has been conducted on the roof shield membrane. In this test, a sample of the roof shield membrane is mounted into a test frame, the upper chamber of which can be filled with water to introduce a hydrostatic head. The test sample is perforated with nails to simulate, for example, counterbatten fixings being made through the membrane. Once the nails are in place, the upper chamber is filled with water, and the rate of water ingress, or not, into the lower chamber is assessed. In this case, no water is able to penetrate through the fixings into the lower chamber. Seen in a cross-section under a microscope, we can see how this sealing process works. The nail does not make a physical hole through the membrane, but rather separates the microscopic fibres around the fixing. These fibres then clench tight around the shank of the nail, forming an effective seal around the fixings, provided the nail remains in place. Our final test case is one of the first projects where roof shield was used, right here in our hometown of Burgary in Perthshire. This is Stormont Lodge Nursing Home. The client wanted to expand their business and due to site restrictions built an additional floor onto the existing building. The new extension was built using timber frame construction and the panels were secured to the existing stonework. The new roof was then built with the timber frame wall panels taking the load. The residents remained in place during the work and one condition of the contract was that the building had to be watertight throughout the entire contractual period. The new roof included softwood sarking, and once the LR underlay was installed to make the roof watertight, the existing roof was demolished and thrown through the apertures into skips below. There was no vapour control layer installed at the ceiling, and the joiner built the loft hatch on site from timber. Below the ceiling are 8 bedrooms, all with shower en suite, and all have electrical downlighters. The BRE then monitored the roof, and these are the results. The figures are for the northeast elevation. The reason for this is that the north-facing elevation of a roof is always at greater risk because it's cooler compared to the south-facing elevation. The moisture content started at between 10.5 to 12%. They peaked in winter when the risk is at its highest, to between 12 up to 15.5%. They then dropped down to between 9.5 to 10.5% at the start of summer. This is a classic curve for our research and illustrates that the roof is working in line with the different times of the year. Unfortunately, a typical detail in construction, and in particular ceilings, is placing round pipes in square holes. This was a detail found on the re-inspection in Stormont Lodge 7 years on. Many other membranes would have encountered condensation problems without a sealed ceiling. It's also worth noting that this project used no vapour control layer, and the loft hatches were simple plywood sheets with no seals. Glasgow Caledonian University summed up the roof performance like this. There is no evidence that condensation has ever occurred in the roof and the timbers show no signs of staining from moisture. It can therefore be concluded that the roof, 6 to 7 years after it was built, is performing extremely well and is free from any risk of condensation. So on that positive note, we'll now conclude our overview of underlays and pitched roofing and move on to your questions in our question and answer session. Good morning, everyone. Thank you very much for joining another one of our lockdown webinars. That's fine. Sorry, we just got a call, so it shows you we're still busy. Yeah, thank you very much. That was slightly longer than our previous webinars. There's just so much information to get through when it comes to condensation control and roof space.
Sorry.
Just bear with me a minute. Don't worry, that customer will get someone to answer that call. It just won't be one of us on this Q&A session. So obviously it is a very special day today, so we're having a 2-minute silence if the questions run over 11 o'clock. So at 11 a.m. there will be a 2-minute silence to obviously mark the special day of V that is today. We're probably best known for our range of membranes in terms of roof shield and wrap-tight. It really is the core of our business and probably one of the reasons why the subject matter was so long. So we do have a lot of questions that have come through email. We have a number that have come through the YouTube chat now. So as I say every week, we will stay on as long as the questions come, and we won't take offence if you have somewhere to be and you need to leave. So please feel free to stay on as long as you like or disappear as and when you need to. You can email us any additional ones at webinar@proctorgroup.com or also post them onto the YouTube feed or DM us on Twitter and we'll try and get around to them all. There are personal CPD certifications available for today's webinar, so follow the link in the description below and it will direct you how you can go about that. We love getting your feedback, so when a follow-up email comes out, which also has a replay, which you can circulate to your colleagues, we really do read the feedback and we take note of it. I personally read all of it, so please fill it out if you have time, we would really appreciate it. We're continuing these Friday webinars every Friday, obviously, at 10 AM. So next Friday will be air tightness solutions for high-rise and modular construction. With a live Q&A afterwards, as always. So registration is open now if you want to register at the moment or today. So go to proctorgroup.com/webinar and you can then register for next week. I think that's it in terms of the information that we need to know. So I'll quickly introduce the team that we have here. I'll start with the newbies, or the newer members that have joined Proctor. So Adam Salt's been with us almost a year. He's a technical sales manager based in Bristol, very knowledgeable on all things Proctor and construction generally. So hi, Adam.
Hi.
Callum Anderson, based in Crieff in Scotland, not too far from me. He's our, sort of expert in WUFI and hygrothermal calculations, and is part of our technical team at head office when it's normally open. Sue Menmuir, also based in Blairgowrie, right near the office actually. Been with us for 27 years. I think I said a few weeks ago, don't let looks deceive you. So again, a ton of knowledge in all things Proctor, Roof Shield and all that stuff. And Mark has been in the construction sector for 34 years and had time with Proctor's a number of years ago. We've managed to entice him to come back and work for us in the past year or so. So we're happy to have him back on board, and again, very knowledgeable. So hopefully between the four of them, we will be able to answer all your questions. So I will just start off. Sue, if I can start with you. We've had one email from Joe. I installed Roof Shield on a roof just before lockdown, and I'm not sure when it will be slated over. Well, this is quite topical actually. So how long can I leave it exposed?
Okay. Generally, we advise obviously that the roof should be covered as soon as possible, ideally within 3 months. However, last year we undertook a program of testing, and we did real-time exposure testing on our membranes. So the membranes were left exposed, completely exposed to all the elements for up to a year. And every 3 months, we sent the samples away to be independently tested. Now, what that has shown is that after the 12-month period, there was no loss in the vapour permeability of the membranes at all. So it gives a degree of comfort to anybody obviously who still has Roof Shield left exposed on a roof, for example, that the vapour permeability aspect of the Roof Shield is not going to be affected at all. Once it's slated in, once it's covered up, it will perform as it's supposed to perform.
Okay, thanks. So obviously we didn't expect a pandemic, so did we just do that for good practice, just something that we do intermittently to check how the membranes are performing over long periods, or?
Yeah, we decided just to do it just to see how they would perform after being exposed for such a length of time. It wasn't just Roof Shield, we did various membranes. We're also continuing that on again this year as well.
Okay, great. That's good timing for us. Great. Well, nice to be able to reassure our customers and specifiers who are using it.
Absolutely.
Okay, Callum, if I can come to you next. We have a question from Rick. How does air permeability change the way that existing roof spaces are handled?
Okay, so with existing roofs, you would typically be using a bituminous felt, so it would be impermeable, and so you wouldn't need ventilation. Or in older properties, might not have a membrane at all. With Roof Shield, you can negate the need for ventilation entirely, which means that, especially in listed properties where you don't want a vent showing on the roof, it can be very useful.
Okay, fantastic. Thanks, Callum. And actually, Callum, can I just ask you another one? I've got you here from the same individual. How does ventilation work around dormers and skylights?
So typically around these areas, you would need an extra ventilation, an extra vent to allow airflow through the roof. But again, with an air permeable membrane, you wouldn't need that, and so you can negate that again.
Okay, fantastic, thank you. Mark, Josh has said, I carry out re-roofing on all types of pitched roofing works, from one-off domestic, heritage to local authority housing. With our changing climate, severe weather can be a problem at times and has resulted in water ingress. What advice would you give, and how would Roof Shield perform in these conditions?
Right, morning everyone. There is general guidance which is given in both BS 5534 and there's also an information paper from the BBA, a technical bulletin paper, and that's paper number 2, and that was published in November 2009. And if you think about the function of breather membranes generally, not just Roof Shield, it's there to provide a secondary barrier, so to prevent ingress of wind-driven rain, snow, dust, etc. into the roof space. It's there to reduce wind uplift, so the forces on the tile of the slate. But it's important to realise that it's not a waterproof barrier, so you will get some water ingress which may occur, and that can be in severe sort of weather conditions. So this will be where you've got constant heavy sort of rainfall. You may have freeze thaw type of cycles and that type of thing. So the recommendations both in BS 5534 and the BBA, and I guess manufacturers' literature, would be to put up some kind of sheeting, temporary protection over the underlay in those type of conditions. So the recommendations really are that you shouldn't leave a membrane fully exposed for more than a couple of days. So, but as I say, in these conditions with persistent rainfall or freeze-thaw cycles, just put a temporary sheet over a tarpaulin or something like that until you've got the primary roof covering installed.
Okay, it's interesting actually, the strain of some of these questions are quite similar. Let's see, we've had another one on YouTube from James regarding about exposure. So I think Sue covered the answer to that earlier, but it's just interesting the type of questions we're getting. Mark, if I can ask you another question, please, that's come in. I'm a property developer and refurbish domestic properties for the rental market. These older properties often require re-roofing, and despite using a breather membrane, well, they're still getting complaints about condensation. How can they prevent that?
Okay, I guess there's a number of factors. It depends on those factors really, and it depends, I guess, on the type of roofing underlay that you're installing. You're not sort of set there which one it is. With existing buildings, you've got to think about a number of different things. So, for example, is the ceiling continuous? Is it a well-sealed ceiling? Have you got the loft hatches well sealed? I'd imagine that you're increasing the thickness of the insulation at ceiling level. So that may be blocking up some of the original vent openings that were initially in place. I guess you need to think about the occupants and their day-to-day activities. So what are they doing? Perhaps are they drying laundry indoors? Situations such as that. Is mechanical ventilation installed correctly? So is it venting through to outside atmosphere? Is the ventilation working? Are the building owners turning that ventilation system off? And then think about the type of membrane that you're going to install, and do a bit of homework really as to the type of membrane you're going to use. So is that membrane airtight rather than air permeable? Does it require a VCL at ceiling level, for example? Does the membrane require you to install perhaps high level ventilation? So these are all the different things you need to think about, and certainly with Roof Shield, it's BBA approved for use without a VCL at ceiling level, so you're not going to be ripping ceilings down to put a VCL in place. You don't need to ventilate, and I think in the 24 years it's been on the market, we've yet to come across a condensation problem.
Okay, great. True. Very good. Adam, morning. One here from Paul. Can the insulation below be in contact with the Roof Shield membrane?
Yes, I think actually in our literature on our Roof Shield brochure, we have all the build-ups in there, and on those build-ups you can actually see the insulation is touching the membrane in certain ones. Now, I think a lot of sort of standard practice and a lot of other membranes require a 50mm gap between the insulation and the membrane. This comes from what we like to refer to as a tenting experience. So when you've been out camping and you're in a tent, you go to sleep overnight, it's been raining, you wake up in the morning, bang your head on the tent, and you've got a wet head. So the same principle with membranes. Now, with Roof Shield being developed up in Scotland, it was important to make sure this tenting experience didn't actually happen, because a lot of the construction up in Scotland, the underlays are fully supported on timber sarking, and we don't want that moisture getting through and affecting the timber. So it was important that we didn't have that tenting experience. So because of that, roof shield can also touch the insulation. Therefore, that 50mm gap can be better used, filling up with more insulation. Now, there is also required a drape for the membrane. So as long as you've got a sufficient drape for drainage, then you can put as much insulation as you like between those rafters. I think the BS 5534, it doesn't state any requirements to what the drape needs to be, but previous versions of the BS 5534 has stated a minimum of 5mm and a maximum of 15mm. So anywhere in between there. But I always like to say, just get a glass of water, pour it down the membrane, does the water run off? If so, then you've got a sufficient drape. So yeah.
Or on a roof, use a plastic bottle.
Yeah, all that. Yeah.
Now, you had a brochure there. Do you have any other props, like how to demonstrate? Because we have a question about how roof shield differs. So does anyone have the bubblers?
I do.
I thought you might, Adam. That's why I was looking at you.
So, being on the road, obviously we carry these bubblers around to demonstrate the roof shield working as best. Basically, it's we put the membrane in the middle of a chamber, and then we put some water on the top into both. So one's got roof shield in and one's got another membrane on the market. Now, the chamber below in both cases have no water coming through. So that means the membrane is withholding the liquid water. Now, all pitched roof membranes, I think it would have mentioned in the webinar, has to be a class of W1 anyways. So we would expect to see this. But if we pump air into the bottom chamber, first I'm going to use the other membrane on the market. We can see, it's hard to demonstrate, but the membrane pulses up and down, but there's no air flowing through that water. So therefore, you would require ventilation of some form to allow that moisture to escape from your roof space. But if we take roof shield, which again, in the chamber, no water's coming through, pump air into it, what we can see is air bubbles coming through the water. That is demonstrating there is airflow, much like a Gore-Tex coat, coming through the membrane and allowing air to pass through, which is why we can then remove vents from our pitched roof systems. So yeah, that's how it works. Better demonstrations in person. So book in some meetings with your local RSM and we'll come down and demonstrate.
So it was great, Adam. Great.
Thank you.
QVC next.
Cheers.
Okay, if I can come on to people on the chat, and we'll go back to Sue and get started with you. So Michael's asked, what membrane would you recommend for a roof that has sarking boards and slate finish? And would this type of construction require ventilation?
Okay, so we have a couple of membranes that can be used in this application. Obviously, we have our roof shield. That is a standard, typical application for roof shield, directly over sarking boards with the slates through it. So that can be used in warm roof, cold roof, even room in the roof design, where you have sort of like insulated coombe sections and then cold sections at the eaves. No ventilation required whatsoever. If air tightness is a consideration, then wrap tight can be used, provided the insulation is also following the slope of the roof and its warm roof design.
Okay, that's great. And Scott has asked Sue as well, would roof shield be suitable as a continuing roof membrane across ventilated and non-ventilated roof junctions, such as a mansard roof where warm single-ply flat roof meets a ventilated rafter roof?
Okay, well, if roof shield was installed on the rafters, there would be no requirement to actually ventilate that roof space at all. Obviously, a mansard roof is a very, very steep pitch roof. You know, sort of like generally, so like about 70 degrees. Warm flat roofs as well do not require any ventilation, provided it's a proper warm roof where the insulation is placed above the structural deck. So in that application, typically no ventilation would be required if using roof shield. We'd probably look more at the size and the design of the flat roof in relation to the pitched roof, but in principle, it can be done with no ventilation.
Okay, thank you, Sue. Callum, one in from Dan here. Why do some people refer to a roof as being a cold roof when the insulation is in between the rafters while you say it's a warm roof?
Okay, so that's a misunderstanding that comes up fairly frequently. In a flat roof, as Sue just said, and in walls, the distinction of whether it's warm or cold is based on whether the frame itself is warm or cold. So if there's insulation outside of the frame, it's classed as warm. Whereas with a pitched roof, it's whether the roof space is warm or cold. So the space inside the rafters. This is defined in the British Standard 5250 rather, in which it says that a warm roof is one where the insulation follows the line of the rafter.
Okay, that's great. Thank you, Callum. And another question: can these membranes be used in walls as well as roofs?
Yes, they can be. The main criteria for membrane being used in walls is that it keeps water out. So it needs a water rating of W2, and also that allows the water vapor to pass through. So it needs to be vapor permeable. Roof Shield does meet those same functions, as well as a number of membranes that we also do. But generally, things like the air permeability doesn't really provide much for the buildings. So a better option might be the wrap tight, which is also self-adhered, and that would add the air tightness that's required.
Sure. Okay. And Cal, one here from Nick on the YouTube chat. Do you think that due to air tightness testing and sealing up of properties, it is increasing the possibility of condensation in roofs with spandrel panels being used more in today's builds? Is that one you can answer? Or?
Yes. So increasing air tightness could increase the chance of condensation, depending on how it's done. With certain levels of air tightness, you would need mechanical ventilation and other factors such as that. The risk of condensation is based on a balance of what the heat, air, and moisture movement in the building is doing. So it could increase the possibility of condensation, but if it's done correctly, then no, it probably wouldn't.
So is that something we would do a condensation calculation, for example, to see if there was any risk and then advise?
Exactly. It would be more project specific.
Fine. Okay, perfect. Thank you very much. Okay, Adam, we can come back to you after your demonstration, then we'll pass a couple to Mark. We've got so much to do on the topic, it's fantastic. But a more sales one for you, Adam. So you are a sales manager. Is Roof Shield expensive?
Oh, right. Okay. Yes. So if we're looking at membrane to membrane, product to product, same sizes, then yes, cost per roll, Roof Shield is more expensive than traditional non-breather felts, for example. But what we want to be looking at is the project overall. So if we're taking into costs associated with ventilation, then Roof Shield will save you money. All pitched roofs are different, but potentially Roof Shield can remove your ventilation, it can remove vapor control layers. You can again increase the amount of insulation, improving the performance of your building. And then on the back of that, that can all lead to quicker install time, less time spent on site as well, less labour costs because you're not having to put vents in and etc. So as a project, you can actually make a lot of savings from a cost point of view. We've actually had independent assessments carried out by Hardy's Property and Construction Consultants. Now that shows that Roof Shield can offer savings, I believe, between 4% and 6%. I think you can find the full report on our website. So, yeah, come with us with your projects, and we will sit down and demonstrate them to you. Really, I think it's best.
Yeah, I did have an email last week that referred to Roof Shield as the Rolls Royce of membranes in the market, which I thought was quite interesting.
Well, yeah, I mean, sorry, just on that. I mean, I've been sat down with a few housing associations lately who've been using a lot of sort of what we class as cheap membranes, and we've been sort of doing some cost exercising with them, and they've been looking at all the sort of savings that they can use using Roof Shield, and they're like, I can't believe we haven't been clued up onto this earlier on. So going into sort of the next year, I think we're going to be doing a lot of them jobs as well, which would be nice.
Yeah. I think just the reliability of the product and the other benefits it offers. But it is a question we do get asked quite regularly, but we look more at the value of the overall roof rather than the square metre price, of course. So.
Yeah, definitely.
Okay, and Mark, quite a long, I always seem to be asking you the long question, sorry, bear with me while I ask this, look at it on the screen here. So from Lewis, with regard to wind uplift resistance, I read in trade magazines that BS 5534 now recommends an additional shielding factor to be applied when using an air permeable membrane. I'm based in Lincolnshire. What impact will this have on Roof Shield and the work I do for regional house builders or the domestic re-roofing works I carry out?
Well, first and foremost, I guess with Roof Shield, we've got a lot of experience, actually live projects, live experience. So if you think the product's been on the market since 1996, there's a lot of live data out there in terms of how the product performs. Yet there seems to be some within the industry that have concerns with regard to how air permeable membranes perform with regard to wind uplift. So as you mentioned in the presentation, an airtight membrane will perform better in terms of wind uplift than an air open. So the theory is that if more air is passing through the roof, prime roof covering, and also through the membrane beneath, then actually that probably puts more of the wind uplift loading, as it were, onto the primary roof covering. So roughly speaking, I guess 2/3 is of wind uplift is taken by the primary roof covering and 1/3 by the membrane. So industry really pushed for an updated shielding factor with the second amendment in BS 5534 back in February 2018. And it did a number of things. First, it gave a clear sort of industry definition as to what an air permeable membrane is, but said that there should be, until there's some further research and test evidence carried out on how air permeable membranes perform. Now, bearing in mind, in February 2018, the product had been on the market 22 years and we had no failings. So the images that you saw within the presentation itself, where the roof tiles have been literally sucked or lifted off the roof, was more actually to do with the fact that when we sort of went back and looked at the projects, nothing to do with the membrane at all. And in fact, some of those cases were not even Roof Shield roofs. In fact, the most weren't Roof Shield roofs. It was due to the lack of the appropriate number of fixings in the primary roof covering. So if you're based in Lincolnshire, then in terms of BS 5534, you're in zone 2 with regard to wind uplift. And I guess if it's new build houses that you're doing, we've got slates or tiles with unsealed joints and without counterbattens. So with the shielding factor that's now in place, if you're using an airtight membrane, the shielding factor is 1, but an air permeable membrane is 1.5. So you think, hang on, well, that's more onerous. So that could mean I need to put more fixings within the primary roof system to account for that differential. But actually, if you read BS 5534 in more detail, it talks about wind uplift on ridge and hips. So if the ridge is fully protected by the membrane, then the shielding factor is 1. But if you're following NHBC guidance with new build and you're using an airtight membrane, then you're probably following the guidance where you need to have the ventilation at ridge. So in that case, the shielding factor where you've got the ridges open is actually more onerous. It's 1.75. So that's more onerous than using an air permeable roof shield membrane at 1.5. So in that case, you'll need more fixings. So with Roof Shield, the benefit really is you're taking that membrane across the top of the ridge. We're going to get less water ingress through that ventilating opening. So that's less water ingress, and it means all the trays, etc., can crack on. So I wouldn't put a great deal of store into this additional shielding factor at all, really. But as I say, it might be worth just looking at it in a bit more detail, perhaps, rather than just taking on board what's been sort of put in the trade press and that type of thing.
Good, perfect. Thanks, Mark. That was a really good answer and very understandable. We're going to have a minute silence at 11 o'clock, so we've got under a minute to go, so I think we'll stop there. But food for thought, one that just came in for Tim, which, Sue, I think I'm going to ask you, seeing as you have the longest experience of Roof Shield. Just a question that says, well, Roof Shield sounds too good to be true, is it? So I'll let you think on that one, Sue, and we can answer after the 2 minute silence. We do have about four other questions through email and 2 or 3 on the chat. So we'll answer those after the 2-minute silence. Hi everyone, that's us back. Obviously just marking the 2 minutes to celebrate VED there. Okay, so if I can come on to, well, Sue, you first actually, if you can answer the question that Tim asked about roof shield. Sounds too good to be true, is it?
Well, I suppose the best way to answer that question is really to use it and try it. But there's a lot of benefits for specifying roof shield. For the designer, obviously, not having the requirement to design in ventilation makes the design so much easier, especially if you're looking at complicated roof designs. For the house builder, there's a cost saving because you don't have the additional accessories that you might need with other membranes, such as tapes, ventilation, etc. The roofer has the benefit because it's so simple and easy to install, time saving there as well. And ultimately, the homeowner at the end of the day gets a healthy and maintenance-free roof space.
Good, good. Roof shield been around for a very long time, and I remember my father, this is not a joke, when asked what his proudest moment was, it was developing roof shield and commercializing it. So it wasn't having his children or getting married, it was roof shield. So yeah, good to be true. Okay, a couple of questions on YouTube, and then I'll come back to the final ones through email here. One from, let's have a look, Clive. Is there a reason that the inner face of the membrane is white? In historic work, e.g. castle roofs, the sarking can be exposed and a white membrane is very obvious in the gaps in the sarking. I'm just trying to think if there's a reason why it's white. I actually don't know the answer to that one offhand. Probably, Sue, you wouldn't know that either, I'm guessing, why the particular reason why.
I'm not sure if there was a particular reason that it was chosen to be white, but one advantage, obviously, that it does give is if you are in the roof space, the light does shine through, so you can still see you know, like it's not pitch black, but I'm not sure if that was an actual designed in advantage.
Yeah, and I think obviously having a differentiated colour makes it more obvious which way it goes.
Exactly.
So it's an interesting question, Clive. So we'll have to think about that in-house, and it's not something that I've heard before, it being raised in historical buildings. And there are different carrier polypropylene colours that you can put underneath. So we have looked at that in the past. So yeah, interesting question. We'll have a look at it in-house. Okay, Nick has asked, why are the regulations asking for very restricted air tightness tests which lead to mechanical ventilation, which then increase the cost of build and the larger buildings will not install?
Okay, so...
Sorry, direct that anyone. I was looking at you, Callum, but I forget you can't read my mind. So yes, thank you, Callum.
Yes, the increasing air tightness requirements they're designed to make the buildings more energy efficient, so the buildings would save energy in the long run, despite being more expensive to build. Mechanical ventilation is a requirement of better air tightness, but it's not always a requirement. It can be designed out at the design phase.
Okay, that's great. Thank you very much. And Sue, I think this question's kind of been slightly answered by Adam before, but if you have anything to add. So when using When using roof shield on a pitched domestic roof over a lounge with insulation in between rafters, should an air gap still be provided under roof boarding?
Okay, yes. So there's no requirement for the traditional 50mm ventilated airspace when using roof shield. Depending on what he actually means by boarding, i.e. is it sarcan board, etc., then the insulation can actually push right up to the underside of the sarcan board, hard against it. No air gap required. If it's open rafters, as Adam mentioned earlier, a slight drape is required just to allow drainage of any moisture down to the gutter.
Okay, that's great. So no more questions. A comment from Nick, which just made me laugh earlier, regarding, what are you just sitting in your pants? I can't speak for the others, but we're not. Yeah. There's so many Zoom calls going on at the moment, isn't it? It's just crazy. It's kind of rushed to change the top and straighten the hair quickly while you're working at home. Okay, Mark, we've got, I think, 3 questions left here, so if I can go to you for this one, Mark. How does the buildup of dirt and debris affect the breathability of roof shield and breather membranes in general? Should I ventilate as well to counteract any long-term loss in performance?
Just going back to the question about the pants, I am fully dressed, but I'd just like to point out the benefits of Crocs. Permeability at low level and at high level, and that's what all the cool kids are wearing. I know our technical director, he's gone one better. He's actually got like leather toe things as well on his. Yeah, so he's the king. Yeah, it's a common question, really, I guess, with that's put against us when we're delivering CPD seminars or we're just talking about vapour permeable underlays generally. There's always a question about how does dirt and debris affect the vapour permeability or the air permeability of roof shield. And I guess if you look at this membrane under, as we've shown in this seminar, if you look at that construction of the polypropylene carrier top and bottom, and then in particular with the roof shield, this air-blown or melt-blown core in the middle, if you were to look at dust or dirt particles on top, they would appear to be almost like boulders, as it were, sat on top. And dust and dirt really is very vapor permeable anyway, so it's not going to have any detrimental effect whatsoever on the ability of roof shield to perform for the lifetime of the building. I guess more of a concern is where you've perhaps got ventilation openings. So as we saw again in the presentation, we've got wind-driven snow coming through as one example, but also dirt and debris. So with the PII research, for example, it showed actually that dirt and debris was being blown through those ventilation openings. So roof shield's a great way of, as it's designed to do, to provide this secondary protection layer against dust and debris.
Okay, good. And Mark, Tony's asked a question via email. How would you repair holes from removed fixings?
Repair holes, we have a fully self-adhered vapour permeable adhesive. It's a wrap type tape, so you can tape up any tears, punctures and that type of thing with the wrap type tape. So it's a fully vapour permeable, fully self-adhered tape system, so you could use that for patching up, etc.
Okay. You've also asked in the same email, are the technical performance principles of Roof Shield also applicable to Wrap Tight and Fire Shield?
Oh, the what, sorry?
Are they applicable? So are they similar technical performance?
In terms of technical performance, you'll need to consider the vapour permeability of these products depending on the application and that type of thing. But there's differences in terms of how these products are manufactured and how they're designed and the type of applications they're going to be used in. So there'll be different physical properties. Some would be similar, so whether it's water resistance, vapour permeability, and that type of thing. But other products such as Wrap Tight are designed to be airtight but vapour permeable. Fire Shield will obviously react differently in the event of fire. Has an active coating on it that reduces that fire spread. So there are some similarities in terms of the physical properties, but they are designed to do different sort of applications, really.
Yeah. Good. Okay. Thank you very much. Adam, if I can come back to you for this one we had via email from another Callum. Can you use Roof Shield on projects where bats are present? This is one we get asked fairly frequently.
Yeah, I think you sat in my CPD the other day, Keira, and I think we were shocked about how many people come across bats in their projects. But yeah, no, the answer is no, actually. You can't use Roof Shield in projects where the bats. I believe only one FL. There are a few others potentially out there, but I don't know too much about them. But one FL, I think, is the only option. We've had independent testing. Roof Shield, I think, potentially outperformed the other membranes, but it still ended up in the same result. So considered, unacceptable. The testing, if you're interested, is carried out using Velcro strips on a rotating drum. And this replicates like a bat's claw, pulling at the membrane. And the limbs of a bat usually features two sharp claws, and those claws will just dig away at the material, allowing those fibres to come up and potentially tangle around their limbs, and then result potentially in them being stuck, and then following on from that. It is something we've been looking into, along with a load of other product developments, which we'll obviously keep you informed of. But yeah, it's at the moment the answer is no with Roof Shield for bats. So yeah.
But as Adam said, we did do testing, and ironically, Roof Shield did perform the best, meaning that they got less tangled, but they still died. So, I mean, it doesn't really give us any benefit over others. So they died slower. So I don't actually know if it's better performing or worse. So unfortunately, we don't have a solution yet, but it is again something that's topical within our business, and we are looking into it. Good. Okay. Sue, if I can just come back to you for the last couple of questions here. What is best practice to deal with Roof Shield at the eaves? Can it be dressed into the gutter?
Okay, so at the eaves, what we advise is we follow good practice, which is to use an eaves carrier in this position here, with the Roof Shield then dressed over the eaves carrier. What that does is it helps to support the membrane at the eaves to prevent any ponding at that point there. So we would always go with good practice and recommend an eaves carrier in this position.
Okay, and I think last but not least, from Jess, I am using fibre cement slates. Do I need to ventilate with Roof Shield? You still do not need to ventilate into the roof space with Roof Shield. What you may find that you will have to do is actually ventilate the batten cavity. And I think this was explained earlier in the webinar, where you have tight fitting outer covering. There is the requirement that you have to ventilate that batten cavity, which may require an additional counter batten, but equally ventilation into the actual roof space is not required with Roof Shield. Okay, fantastic. The same with any membrane. It's not necessarily just Roof Shield. Anything sort of like above the membrane is out with the function of the membrane, and it's more of a requirement of the slate or tile manufacturer. Okay, good. Great, so that's all the questions, I think. Something in from Pasty Steve or Pasty Steve, I'm not quite sure how you pronounce it. Thank you very much for acknowledgement of using our products. It's appreciated, you know, from a contractor point of view, that you find this informative and interesting. And I hope you all have. We know it was VE Day. We planned another webinar on a bank holiday. Not on purpose, but we decided to go ahead because we, you know, the last one was successful. So we will note again not to plan one on a bank holiday. But, you know, it's become a firm slot in our diaries now, and we're more than happy to keep doing these weekly webinars at 10 a.m. And actually, we really enjoy doing them, and we love reflecting afterwards. We have a meeting, you know, after lunch, and we go over the type of questions that we're asked, what we can do better. You know, anything that we can do to help improve the business or the experience that we're giving to the customers or the potential clients that are listening. So thank you very much for being here, everyone. I want to thank the staff here, or colleagues and peers on the Q&A. Thank you very much, guys. I know it's not easy answering the questions off the hoof, and I think you've all done great. Appreciate it. And thank you to the marketing team who are frantically working on next week's webinar now. So you've seen the visuals. You know, there's a lot of time and effort that goes into these webinars. So they're challenged at the moment and really showing their skill set. So it's fantastic. Next week at 10 o'clock, we have another lockdown webinar, which is air tightness solutions for high-rise and modular. So that one's quite kind of specific and targeted. So Mark is our high-rise and modular business development manager. So he'll be joining us on that, along with a couple of other faces, either from here or from the team that are home working at the moment. So that will be really interesting. And it's, again, we'll cover some of the you know, it's solutions for the recladding on the high-rise sector, which again is very topical at the moment. So the team are working on that at the moment. You will receive an email shortly after we finish today, which again has a replay. So please send it to colleagues or friends if you think they'll be interested. Link to a survey. Again, if you can fill it out and you have time, we would appreciate it. As I said before, we don't take offence. We're really interested to hear what you have to say about the content and the quality, and any suggestions for this webinar or for our future webinars. CPD certificates are downloadable on our website. So if you look at the link below, you'll be able to go and get one right now or at a later date. That's fine. So please register for next week. It is open now. The team have put the page up during this webinar. So go to www.proctorgroup.com/webinar. So thank you very much to our regular viewers. Thank you to new viewers. And we hope to see you next Friday, and enjoy the rest of the day. I think you guys are in for some good weather down south. Us up here, not so much, but have a good day and enjoy the rest of your weekend.
Thank you.
Thank you.
Thanks.
Bye.
Bye.